Hey grade 12s, and welcome to this video. So in this video we're going to be working on question 4 and question 5 of the Gauteng 2022 paper 1. So the first question in question 4, 4.1, we are first given f of x is equal to 8 over x minus 2 plus 2. And we are told to write down the domain of f. So for a hyperbola, the domain is always going to be x is an element of real numbers, but x will not be equal to a particular number. X will not be equal to the x value of your vertical asymptote, and that would be it. So where we have x minus 2, our vertical asymptote, or the value of p would be equal to 2, meaning the equation of your vertical asymptote is x is equal to 2. Because an asymptote is a line that the graph will never pass, then we will not have x values of 2 for this graph. So the domain of this graph is x is an element of real numbers, but x is not equal to 2. And so you can think about it like this. So here is your vertical asymptote. It's this vertical line, and it will be passing the x-axis at 2. And that's your horizontal asymptote. So we're just looking at all the possible x values of this graph. So as you can see, this graph, look at a point over here. Point over here will have an x value of that. Point over here has an x value of that. And it keeps having x values for everything really. But then when we get to 2, it doesn't have any x value here because there's an asymptote. And then after 2, it will have an x value somewhere up there. There, it has an x value after 2. And still here, still has an x value after 2, and it will keep having x values for everything, positive and negative numbers, except for 2. Okay, so that's it for 4.1. Moving on to the next question. So the next question, 4.2, is to calculate the y-intercept of f. Remember, when you're trying to find the y-intercept, all you have to do is just make x equal to 0. And that's what we're going to do here. So we have f of x, but in place of x, I'm going to put 0. So this is now f of 0 is equal to 8 over 0 minus 2 plus 2. And so f of 0 is going to be equal to 8 over 0 minus 2 is negative 2. So that's 8 over negative 2. So 8 divided by negative 2 is negative 4 plus 2. Negative 4 plus 2, that's like saying positive 2 minus 4, which is negative 2. So f of 0 is equal to negative 2. And I'm just going to go ahead and leave it like this because they didn't really ask for the coordinates of the y-intercept. Okay, moving on to the next question. So 4.3 says calculate the x-intercept of f. So the x-intercept, we will find that simply by just making y equal to 0. So let's take our equation and make y equal to 0. So f of x stands for y, so we're going to make that equal to 0. So we're saying that 0 is equal to, and we'll have 8 over the x minus 2, and then we have, of course, the plus 2. And now in order to solve for x, we can take 2 over. When you take 2 over, it becomes negative 2 is equal to 8 over x minus 2. And then now, because you have a number here, and an equal to sign in between them, first of all, we can start by making this a fraction by putting it over 1. Then we're going to cross multiply. So we're going to say the 8 multiplied by 1, or 1 multiplied by 8, that gives you 8. And then we're going to also just say the negative 2 multiplied by x minus 2. But remember, the negative 2 has to multiply into the x and the negative 2. So I just like to write it as negative 2 bracket x minus 2 at first. Now, in order to solve for x, you could FOIL in, but you could also just get rid of the negative 2 so you can get closer to the x. So we can divide both sides by negative 2. And so 8 divided by negative 2, that's going to give you a negative 4. And that is now equal to, that cancels, and we have x minus 2. Then we can take the negative 2 over, and so it becomes a positive 2 minus 4 being equal to x. And so x is equal to 2 minus 4, which is negative 2. And so that is the x-intercept of f. And then question 4.4 says, sketch the graph of f, clearly indicate the coordinates of the x and y-intercept as well as the asymptotes. Okay, so in order to sketch graphs, I like to use steps, and I just try to keep these steps consistent. So first, we're going to look at the shape of the graph. the shape of this graph depends on the value of a. So remember, the equation of this function is this, and so it's really in the form of y is equal to a over x minus p plus q. So the value of a, as you can see, is a positive number. It's 8. When a is positive, it means that your graph, since a is positive, your graph is going to lie in the first and the third quadrant. So that we know about the shape of the graph. And then the second thing we can look for are the asymptotes. So when we're looking at the asymptotes, remember we have a horizontal and a vertical asymptote. This one, the P, will be your vertical asymptote. So the equation of that is going to be x is equal to, so it's not going to be the -2, it's like taking the -2 over an equal to sign. So it becomes x is equal to 2. That is your vertical asymptote. Then the horizontal is just y is equal to whatever number is there. So that's just a +2, we leave it as that. So those are the equations of our asymptotes. X is equal to 2 and y is equal to 2. Then the third thing we just have to look for is our intercepts, x and y intercepts. And we know that the x-intercept, we already found that it's actually the same thing really. So the first one, the x-intercept is -2 and 0, because it has to be as a coordinate, -2 and 0. And then the y-intercept was also a -2. But as a coordinate, the x value is 0 and the y value is -2. So that is 0 and -2. And now that we have everything, we can just sketch it down. Okay, so for the graph, I'm just drawing a Cartesian plane that is just going from -5 to +5 on the y and the x-axis. So that's our x-axis and that's our y-axis. And so first, what you can do and what is much better to do at first is to put down your asymptotes. So we first have a asymptote of x is equal to 2. That is the vertical asymptote. So the vertical asymptote is just a vertical line going down like that. And I'll put that in blue. And so here's our vertical asymptote. Also, just make sure it is going on as well to infinity. Also, just make sure to label it. The equation of this line is x is equal to 2. Okay, because it has an x value of 2, but it has multiple y values. And then we're going to also label the horizontal asymptote, and that one is y is equal to 2. So that would just be a horizontal line passing the y value of 2 on the y-axis. So here is our horizontal asymptote, and the equation of it is y is equal to 2 because it has a y value of 2 but multiple x values. And then we can put down our intercepts. So the intercepts we have is we have -2 and 0. So -2 and 0 is an x-intercept. And we could just go ahead and put that here, -2 and 0. And then we have 0 and -2. So that's 0 and -2. That's a y-intercept. Now all we're going to do is just draw this graph. Remember that because a is greater than 0, your graph is going to lie in the first and the third quadrant. So it's going to lie in this quadrant and this quadrant. So when we draw this graph, it's going to come from the asymptote, close to the asymptote, and then it's going to pass the x-intercept, then the y-intercept, and then it's going to move down, moving closer and closer to this asymptote, but it will never touch the asymptote. So something like that. It's just going to keep moving down like that. And here it is going to be coming from this asymptote, being very close to this asymptote. So that's just the part of the graph that lies in the third quadrant. The one that lies in the first quadrant, you can, if you want, you can substitute an x value like 3, for example, into your graph just so that you can see the y value and then sketch that. But it's not really necessary. You know that if this looks like that, then this one is obviously going to do something like that. So something like that. Okay, so it doesn't have to look perfect. It just has to make sense and have the points that it's supposed to have. So there's checking the shape of the graph that you put your intercepts, your asymptotes, and their equations as well. It's always important to label the equations of these asymptotes. And also, just because this graph is called f, I will just label it f. Okay, moving on to the next question. Then question 4.5 says, if y is equal to -x plus k is an equation of the line of symmetry of f, determine the value of k. So if this equation is the equation of the line of symmetry of f. So just remember, f is a hyperbola, and so it has two lines of symmetry. It has a line of symmetry with a positive gradient, so this one is an increasing function. So you see that as we move from left to right, the graph is increasing, so its gradient is positive or greater than 0. And then it has a one with a negative gradient where it is a decreasing function, so the gradient is less than 0. As you can see in this equation, y is equal to negative x plus k. It is in the form of the general equation of a straight line, which is y is equal to mx plus c. So you can see that the gradient, okay, is actually -1 in this case. So this is the equation of the line of symmetry with a negative gradient. That's what they're referring to. So we just need to find the value of k. What exactly is its y-intercept? Okay, so we have to find the actual equation of the axis of symmetry with a negative gradient. So to remember this, just remember that this is how this works. The axis of symmetry, let me actually draw it in this hyperbola. So with the axis of symmetry, there are dotted lines as well because it's an axis of symmetry, but I'm going to just use a straight line. So it's a line that is going to pass this middle, this intersection of your asymptotes. And then that is the positive one. So I'm only drawing the positive one so that you can see how to come up with the negative one's equation. So if this one's equation is actually just y is equal to, and then we say x minus p plus q. And it's actually easy to remember as long as you remember the general form of a hyperbola as y is equal to a over x minus p plus q. See that x minus p plus q, that's exactly how it looks. This one is just y is equal to x minus p plus q. That's the one with a positive gradient. Then the one with a negative gradient is going to be decreasing, and then it's going to look like this. It's also going to pass this point of intersection. So that one is going to look like this. It is y is equal to the one with the negative gradient. It is y is equal to, and all we do is we put a negative in front of the x minus p. So negative bracket x minus p and then plus q. Then you can go ahead and multiply that negative in. And so it's going to be negative x plus p plus q. That is the equation of that axis of symmetry, or that line of symmetry. So that is the equation. If we know it's y is equal to negative x plus p plus q, then as you can see, all we need to know is the value of p and the value of q. The value of p and q can be found in your asymptotes. You can even use the actual equation of the hyperbola. So here, the value of p is your vertical asymptote. P is equal to positive 2. So remember, I know it is a negative here, but you must always take it's kind of like multiplying it by -1. Always take it as if you're taking it over an equal to sign. And then q is equal to whatever this is. It's just a positive 2, so that is positive 2. So since p is 2 and q is 2, all we're just saying is y is equal to negative x plus 2 plus 2. That's all we have here. So y is equal to negative x and then plus 4. So as you can see now, it's in the same form as this equation. And so it means that k is equal to positive 4. Okay, so sorry for that long explanation, but it was just for you to remember in case they ever ask you for the one with the positive gradient as well. Okay, moving on to the next question. So 4.6 says, determine the equation of the graph which is formed if f is shifted 3 units to the right and then reflected across the x-axis. Okay, so there are some translations happening to f here. First of all, f is shifted 3 units to the right. Okay, when a graph is shifted 3 units to the right, let's look at the equation of f first of all. So if this is the graph of f, when a graph is shifted to the left or the right, that affects the x value. Okay, so that is going to affect that x value. And really, all the x values of this graph is going to shift 3 units to the right. And so how we apply that on the equation, this is really what I'm saying here. I'm saying that the new graph, first of all, we have f shifting 3 units to the right. So we have x here, first of all. When a graph is being shifted to the right. It's not going to be a plus when you're applying it to the equation. It's going to be a minus, and this only applies to the x. So it does not apply to moving the graph up or down, which affects the y values. Only applies to when you move the graph left or right. So right movement is minus. And so because it's moving 3 units to the right, we're going to say x minus 3. Okay, and let's see what happens when we do that. So we're still going to have 8 over, and then we have x. And then now we're going to have a minus 3. You can put the minus 3 here, or even after the negative 2 is still fine. So I can say minus 2, then minus 3. And then we still have plus 2. Okay, so long, this new graph, f of x minus 3, so long, just looks like this. 8 over x, negative 2 minus 3 is negative 5 plus 2. That's what the shift 3 units to the right looks like. First of all, this is what it does to the graph. Okay, so take it step by step. So we've done that now. Now the second thing they say is that it's then reflected across the x-axis. When something is reflected across the x-axis, imagine it like this. You have a graph like this. If it's reflected across the x-axis, then it means that it's going to form a mirror image here. So it's going to look like that. So if you notice, looking at this black graph and looking at this red graph and see what happened is that here we still have all the same x values for the black graph and for the red graph. The x values did not change. What changed was the y values, because this graph had these y values, positive y values. But now when it's reflected, look at the y values it has. It has negative y values. So when you reflect a graph across the x-axis, it causes the y values to change. Okay, and how we make it change, because you saw that the other ones were positive and then the other ones became negative when we reflected it. You really just multiply the y values by -1 or by a negative. And so looking at this equation that we have, what represents the y values? Just like we have f of x represents y. Okay, it's the same thing as saying y is equal to 8 over all of this. So since this represents y, what we're going to do is we're going to multiply a -1 to the y. So we're multiplying -1 to the y values, but we're not multiplying it to this original equation. Remember, we are working on this one. After translating the 3 units to the right, we need to change all the y values to become negative. So it's like taking this and we're multiplying it by a -1. We're taking f of x minus 3 and we're going to multiply this by -1. So see this as becoming a negative f of x minus 3. Now, what represents f of x minus 3? It is this equation, this current equation here, 8 over x minus 5 plus 2. That is equal to f of x minus 3. So this is all we're doing. We're putting a negative, and then in place of f of x minus 3, we're going to put this equation. As you can see, this equation has 2 terms. This is the first term, and this is the second term, because terms are always separated by plus and minus signs. So all we're going to do is put brackets, and we're going to put 8 over x minus 5, and then we have the plus 2. Then this negative is going to multiply into this. So if it multiplies, the -1 can multiply into the 8 instead. So that becomes a -8 over x minus 5. Then the negative multiplies into the +2, making that -2. So this is your new equation. So if I'm writing the equation as a whole, like what is the subject of this equation? Remember, we made this negative, because this is really it. We made this, we multiplied this by negative, and we shifted the graph 3 units to the right. So it's really negative f of x minus 3 is equal to -8 over x minus 5 minus 2. And that's the last question for question 4. And now we're moving on to question 5. Okay, so now we're on question 5, and question 5 says the graphs of f of x, which is equal to 2 bracket x plus 1 all squared minus 8, and g of x, which is equal to 1 over 2 all raised to the power of x, are represented in the sketch below. P and Q are the x-intercepts of f, so here's P and Q, and R is the turning point of f. Then we have a point A, which is -2, and 4 is a point on the graph of G. And the first question, 5.1, says, write down the equation of the axis of symmetry of F. Now, the axis of symmetry is a line that cuts the graph into two perfect halves. Or you can also see it as it's a line that cuts the graph in a way that they look symmetrical to one another when looking at them between this line. So when looking at the parabola is always symmetrical about its turning point, but the x value of its turning point. So here, if this was the x value of the turning point over here, you will notice that this part of the parabola is going to look exactly the same as this part of the parabola. It's like this is a mirror. And so if we have this part of the parabola, when we see the reflection of it, it's going to look exactly like that. So it's symmetrical about that turning point, but the x value. And so we have to find the x value of the turning point. So the x value of the turning point is, as we can see here, this is put in turning point form. It's put in the form of y is equal to a bracket x minus p all squared plus q. And so p and q will always be your turning points. But notice this said minus p, but here I put a positive p. So that the p always changes its signs. So if we have a positive 1 here, this needs to become a negative 1. And the negative 8, it will just stay the same. Like this is positive q, that's also positive q. So that is what we're going to have there. But this is our x value of our turning point, and that's what we have to focus on. Also notice that they said they want the equation of the axis of symmetry. The equation of that line, since we know this is its x value, negative 1. The equation of this line, it's a vertical line, will be x is equal to negative 1. Okay, so moving on to the next question. So the next question, 5.2, for 1 mark, they want you to write down the coordinates of R, the turning point of F. So the coordinates of R would just be, as we have seen here, this is the turning point. Since we have negative 1 here, the Q value is just whatever is here, okay? And it's negative 8, so we take it like that. So the coordinates of R are just negative 1 and negative 8. So 5.3 says, determine the coordinates of P and Q. So remember that P and Q are your x-intercepts of your parabola. In order to find the x-intercept, just make y equal to 0. So this is the equation of our parabola, so I'll write that down. And we're just going to make the y value equal to 0. So we're making this 0, and then it's equal to 2 bracket x plus 1 all squared minus 8. Now, I know many a times in order to solve for this, we go ahead and just expand this, but this takes long and then it leads to factorization. There's a way you can simplify it without having to factorize anything. So we're going to take, first of all, this negative 8 over to the right hand side, and so it will become a positive 8. So 8 now is equal to, then we have 2 bracket x plus 1 all squared. Remember, we're just trying to get to the x. So what is stopping us from getting to the x? The first problem we have is this 2 before the 1. The 2 is a problem. So we can divide both sides by 2, and then 8 divided by 2, that is 4, is equal to, that's gone. Now we have x plus 1 all squared. Okay, now that we have that, we just have to solve for x. To solve for x, the squared is blocking us. So we need to get rid of the squared by square rooting both sides. So if we square root both sides of the equation, you just have to remember this one last thing. In front of the number, you need to put plus and minus because you're square rooting. The positive and negative answer for that will work. So you have to take plus and minus. And so the square root of this, we're going to have positive or negative. Square root of 4 is 2, is equal to, then we have x plus 1 without brackets. And then all we have to do now is take the 1 over to solve for x. If you take the 1 over, it will become a negative 1. I advise that you put the negative 1 in front of this plus minus. So it's negative 1 plus or minus 2 that is equal to x. And there, so now we can now conclude. We can say that x is either equal to, so it's first the negative 1, then we can choose the plus first, so plus 2, or x is equal to, again, the negative 1, and then now we choose the minus 2, so minus 2. And so we're going to get x is equal to negative 1 plus 2 is like saying 2 minus 1, positive 2 minus 1, which is 1. And then x is equal to, or x is equal to negative 3. So those are the x-intercepts. But remember, they want it as coordinates. They want coordinates of P and Q. So we need to also label them. So let's just look on the graph to see, since this is positive 1 and that's negative 3, it would mean that since this one is negative, that's the negative 3, and that one is the positive 1. Okay, so it means that P is therefore negative 3 and 0, and Q is 1 and 0. Okay, so just make sure to conclude if they say coordinates. Then moving on to the next question. Then 5.4, for 2 marks, we have determine the equation of g to the power of negative 1, the inverse of g in the form of y is equal to. So to determine the inverse of the equation of g of x. So this is an exponential. Since this equation is 1 over 2 to the power of x, I'm just going to write it in the form of y first. So y is equal to 1 over 2 raised to the power of x. To find the inverse, first swap the x and the y. So in place of x, I'm going to put, in place of y, I'm going to put x is equal to, then we have 1 over 2. And then in place of this x, we're going to put the y instead. And then now you have to make y the subject. So that's only 2 steps. Swap x and y, make y the subject. In order to make an exponent the subject, you have to use log. So we're going to say y is now equal to, and we're going to say log of the base that we have is 1 over 2. The base is always the number carrying the exponent. So log the base is 1 over 2. And then in here, in the brackets that will be here, we're going to have the x. But you don't have to put it in brackets. You can just say x. Okay, so that is the equation of that in the form of y is equal to. That's the inverse. Then we have 5.5 saying sketch the graph of g of the inverse basically in the answer book. Clearly indicate the intercept with the axis and at least one other point. So when they're asking for these things, there's hardly any calculation that needs to be done because they're specifically asking for one other point. If you look at the way this graph looked, the exponential function, it had one point. The point it had was the negative 2 and 4. Now when you have an inverse graph, the inverse just swaps. All the x and the y values swap. So the x values become the y values and the y values become the x values. So this point A, when it is on your inverse, it's going to say 4 and negative 2. That's the other point that we have. Then the intercepts that it has. We're going to have to think about what intercept does this original graph have. So as you can see, it doesn't have any x-intercept. This graph doesn't have any x-intercept. It only has a y-intercept over here. So really all we have to find is that y-intercept. And so to find this intercept, if we make x equal to 0, so as you can see, x is the exponent. So if we had 1 over 2, and now we made that x value equal to 0 so that we can find the y-intercept, then we will find that this is going to be equal to 1 because anything raised to the power of 0 is 1. So that is 1. And that's something you're going to notice about these graphs that have a horizontal asymptote of 0. These exponential graphs, their y-intercept is usually going to be 1 when it is above the asymptote. So think about it like this. If this coordinate over here is 0 and 1, and we also have this coordinate A, then all we have to do is on the inverse swap these values. So it means that on the inverse, the intercept we will have will not be a y-intercept because this will swap. The inverse is going to have 1 and 0 instead. And so it's going to be an x-intercept. So that's the first point we have on our inverse. We have 1 and 0. And then the second point is, of course, the swap of this one. So it will be 4 and negative 2. So I'm going to just call that A prime just to show that it is the image of A. So it's going to be 4 and negative 2. Okay, so that is the intercept that they're referring to and the one other point. And now we have to actually sketch the graph. Okay, so now that we have the coordinates down, let's just see what the x and the y-axis is going to look like. Okay, so now I just want to see what my y-axis is going to look like. Just plan this out so that at least the graph will be neat So we can just start at, since we have 0, we have -2. Those are the only y values we have, meaning the smallest y value is -2. So I'll stop at like -4. And then the biggest y value is 0. I can just stop at 2. That's okay. And then for my x values, I will start at, so the smallest one is +1. So I'll start at like -1 and then end at 6. Just so I can go a bit further than what 4 is, and it will just give the graph a bit more form and shape. Okay, it is best to start drawing the y-axis because it just helps you to know exactly where on the page is going to be, and it's just less erasing. Okay, so I'm starting with the highest value so I know where to stop. So 2 going down. Okay, and then, you know, on your page, you'll just be able to erase all of that because you see you don't need that. Okay, so the y-axis is done, and then the x-axis. Okay, and then I'll shorten it a bit. And so this is our x-axis. Okay, so this is what the Cartesian plane looks like. So now we can just plot down the points. So that was just for the axis. Okay, so the first point we have 1 and 0. So I'm going to put 1 and 0. So there we have that x-intercept. And then we have 4 and -2. So 4 and -2 over there. 4 and -2. So I put that coordinate down because it's not an intercept. With the intercept, they will know what that is, but you can also write it down as 1 and 0. And then now this is how to draw this graph. You have to look at this one, and you can actually use your question paper to practice on how your graph is going to look. Because you know where these points are. These points are over here. We have 1 and 0, and we have 4 and -2. You can also just try to put points like that on here as well. Okay, so here are the 2 points that we have. And so to draw this graph, all we're going to do is look at the way this one is. Since this one is the inverse, it's really just going to do not the opposite. It's going to do the exact same thing that it's doing here, but instead, what it's doing on the x-axis here, it will do on the y-axis here. And what it's doing on the y-axis of the original graph, it will do on the x-axis of the inverse. Okay, so now to see what it is doing, let's look at the G graph. Okay, not the inverse first. So this one, as you can see here, let's use a point that we have. Over here, this point, okay, has a negative x value, and the y value is positive. So this one will have a negative y value, and its x value will be positive. So that's what's going on here at this point. It has a negative y value with a positive x value. And then over here, this graph starts to decrease. It starts to move down. As it is decreasing, notice that the x values are moving towards the positive part of the x-axis. So this graph, the inverse, will also start to decrease, and then the y values will be moving towards the positive part of the y-axis. So it's going to do this. And as you can see, this one gets closer and closer to the x-axis, and then the red one will get closer and closer to the y-axis. So it's going to look like that. It's going to slope like that and move closer and closer. So that's what I mean by it's not doing the opposite. What it's just doing is what this one is doing on the x-axis, the inverse will do on the y-axis. And what this is doing on the y-axis, the inverse will do on the x-axis. So that's how this graph is going to look. It's going to come from the top and it's going to slope down. So always use your original graph to practice. So it's going to come from the top and slant down and move closer and closer to the y-axis, but it will never touch the y-axis. So it's going to do something like this. So it's shooting up here, and then it's moving closer and closer to the y-axis. Okay, so that is the graph, and you can label it G-1. Okay, moving on to the next question. So the question 5.6 says, for which value or values of x is the inverse greater or equal to -2? So remember, when they're talking about the inverse, they're referring to the y values of the inverse. If they say g of x, it's y values. G-1 of x, that is still the y values of the inverse. So the only reason they'll be giving you -2 is because you have that point on your inverse. So if you look on the inverse, you see we have -2. They want to know for which values of x it's either going to be greater than negative 2 or equal to negative 2? So let's talk about where it is equal to negative 2. So where does it have a y value equal to negative 2? So over here, where the x value is equal to 4. Okay. Then they also want to know where is it greater than negative 2. Where are the y values of this graph greater than negative 2? So here is the y values that are greater than negative 2. It'll be everything that is here. So as long as the graph has y values that are greater than negative 2, we will take them. So this will be the y values we'll take on this graph. We're going to take everything that has a y value greater than negative 2. So that will be everything here that has y values greater than negative 2. Okay, it's negative 2, everything with y values greater than negative 2. And now we're going to find out what are the x values that belong to this part of the graph that has been highlighted. Well, to find out the x values, the first x value we have is 4. Okay, so that is where the graph itself has a y value of negative 2. So it's first here. And then if we keep going, look at how these y values look. It's here, it's here. So we can compare to 4. These are values that are what than 4. These are values that are less than 4. And we keep going. It's still values less than 4, still values less than 4. And we keep on moving on this graph. But then you will notice that it will not go past the y-axis because the y-axis is now an asymptote. So on the original graph, you would have noticed that we had a horizontal asymptote here. Okay, so if I erase all of this, we had a horizontal asymptote of y is equal to 0, okay, on the x-axis. But in the inverse, whatever the x's are, they become the y's. So now instead of a horizontal asymptote, we have a vertical asymptote of x is equal to 0. So that really just means that we will not have any x value that is 0. Okay, the x values will never be 0, and also it will never go past these x values. So this graph will not exist for any x value that is smaller than 0 or equal to 0. So it's really just going to stop here. It's going to be between 0 all the way to this x value of 4. So as an inequality, what's going on is that we have x values that are greater than 0 but less than or equal to 4. And it's equal to 4 because they ask for greater or equal to negative 2. Okay, and the x value that has a y value of negative 2 is 4. So this is the inequality. It's where x is greater than 0 but not equal to 0 because there's an asymptote there, but less than or equal to 4, of course, because they ask for greater or equal to negative 2. That would be your inequality there. Okay, so that's just our answer there. X needs to be greater than 0, but less than or equal to 4. And that would be the answer for that first one. And then the last question is 5.6.2, for which values of x is x multiplied by f of x less than 0? So this is really what they're saying. For which values of x will the x values of f of x multiplied by the y values of f of x be smaller than 0? So to find this, you have to think about what kind of numbers do you have to multiply together that will give you numbers that are smaller than 0, or let's say numbers that are negative, because that's what smaller than 0 means. So if we think about that, if you take a positive number and you multiply it by a negative number, you're going to get something smaller than 0. So this is where I'm saying that the x values could be positive and the y values could be simultaneously negative, and then we'll have a negative answer. Also, the x values could instead be negative multiplied by the y values being positive, and we would also have a negative. And now we just have to find this on the Cartesian plane. So because we're talking about f, we're going to look at the parabola. Okay, because we're speaking about f, let me just highlight f so we can only focus on f. Okay, so here is the graph. And remember, this is really all we are looking for. So I've just written it down and I'm going to put the positives in pink and the negatives in blue. Now, this question is actually one of the simplest types that they can ask you, because with these ones, you really just get to focus on certain axes or certain parts of the axes that we have. So since the first one we have to find is this, we have to find out where are the x values positive and the y values negative. Okay, first of all, let's focus on the axes that have these. So where is the positive part of the x-axis? So where on the x-axis do we have positive values? That would be over here. And then we have to find out where do we have negative y values. So we're looking for y values that are negative. So on the y-axis, these parts have negative y values. And now all you have to do here is state which quadrant this is in. This happens in the fourth quadrant. And then highlight where you see the graph. The graph is over here in the fourth quadrant. This is the only place that the graph exists, in the fourth quadrant. Now we just have to state the values of x for which this part of the graph exists, this. Okay, but just remember the x value of q was 1. We found that x-intercept already. We also found this one as -3. Okay. So this is all we're going to do. We're saying the y values multiplied by the x values. So negative y values, positive x values. Now, the reason we cannot take this, like the one that is on the y-axis, is because over here, this y value may have a negative number. But the x value belonging to this has a value of 0. So imagine what's going on here. We need to find where if you take a y value and you multiply by the x value, it's going to give you a negative number. But over here, the y value is a negative number. We can see that. But multiply by the x value is 0. That would not give you a negative number. That would give you 0, because anything times 0 stays 0. So I just want you to notice that we're not going to take the actual x value of 0. We cannot say x is equal to 0. But yes, we know 0 is a starting point. So we see that this part of the graph, the one that is highlighted in dark green, sort of a color, so that is going from where x is greater than 0. So we can actually just point it out like this. It's where x is greater than 0 but less than 1. And I can also not say less than or equal to 1, and this is the reason why. At 1, the x value of this may be a positive number, but the y value at this point at q, the y value is 0. So if I multiplied it by a y value of 0, I would get 0, not a negative number. So I also cannot take the actual x value of 1. So the values of x for which this part of the graph exists is going to be where x is greater than 0, but less than 1. So that's the first one that we have. We found this one. Okay, then we also have to find the other one as well, where the x values are negative and the y values are positive. Okay, so where are the x values negative? On the x-axis, the part of the x-axis that has negative values are over here. Here we have negative x values. And then we need to see where the y values are positive. So on the y-axis, we have positive values over here. And now you just have to state which quadrant this is. This is in the second quadrant. Then highlight wherever the parabola is in the second quadrant. The parabola is in the second quadrant, all over here, and then it stops there. Then you see nowhere else in the second quadrant do we have the graph again. So now we just have to state for which values of x this part of this darkly highlighted graph exists. And so if we point that out, let's just see where this exists. It's going to exist here. So starting at -3, and then you see that we have a point over here. That's the x value. So remember, this point over here is -3. Then look at that. These are values that are what? Than -3. These are values that are less than -3. That is the x values for which this part of the graph exists. So in this case, this will be where x is less than -3. Again, we cannot say less than or equal to -3 because at -3, this is an intercept, meaning yes, the x value may be negative, but if you multiply by the y value, which is 0 at this point, we're going to get a 0 and not a negative. That's not what we're looking for. We're looking for where we multiply these x and y values and they give you a negative. Okay, so we also found that one as well. So that will be your conclusion. That is the part of the graph where x multiplied by f of x will be smaller than 0 because we're referring to the parabola. So that's your conclusion in that question. It will just be, therefore, x is less than -3, or x is greater than 0 but smaller than 1. And that's the end of this video on functions. And I hope to see you in the next video on financial maths question 6.